Hello guys, this is Giovanni di Grezia, and today I'm showing you a tool I developed in 3dqualizer, and this tool is called Adjust 2D Curve Local Filter. Usually we create and filter curves because these curves are not good. For example, if we select this curve, we can center 2D, and we can say that this curve is stable, is solid enough, because we can see the points is only shift for few pixels. It's in gold, based on the quality of the footage. But if you can see this point here, this point has been triggered like other one points, you can see that the motion is a bit shaky. So you should fix this, and usually the solution to fix this is to filter this curve. So we can use, for example, transform 2D tracks. We can filter them, apply, but we don't know. We should apply the filter on all of them. Or, for example, we can open the edit tracks, another script provided by 3dqualizer, and here we have the two tracks position X and Y. For example, if we say the position X, we can see that it's shaky. We should filter them, select, filter, click, and bam, we can filter these curves. We can also revert to original, but we don't have control how to optimize these points. An idea should be to create an adjustment script to optimize a single point, but this is very a madness. This is an insane operation, because we should create an optimization for this point, and for example we have adjustment curve vertices. We should optimize this point between, I don't know, for example, between a range 0, 51, 51 and 52. So this point should be allowed to go until reaching the 0.52, and on the bottom 0.51. So you can do this. So we can add adjustment for this, for this, for this, and if we have, for example, 10 samples on these vertical lines, we should have 10 variation here for multiplying 10 variation for this point, and 10 variation on this point, and 10 variation. So it will be 10 elevated to 2, 3, 4, 5. So we also, with only 4 frames, you can have 10 for 10 for 10 for 10. So we have 100,000 and millions of variation using only a few frames. So the idea is to create a script to filter curve in range. So for example, I can create this, I can filter this piece, this range, I can filter this, I can filter this, and so it's different. The approach is different, because I have to say to the equalizer, please take this piece. I set a filter margin, a bottom and a top, so we can optimize the curve. But let's see how the adjustment looks. We can open it using adjustment, adjust 2D curve local filter, and selecting this point, we see this interface. We can click load curve, we see the loaded curve onto the X and Y. If we click this and we press local curve, you can see that this curve is more stable, seems to be steady, and you can see there are less variation on the x-axis. But if we select this point here, we have a continuously random offset and variations on the x-axis. In fact, we can see them using and scrubbing on the timeline. You can see that this point is not very stable. So we can optimize this. And in how we can optimize and filter this, we can use the Fourier filter. And we can have a global here. We have a global filter. And we have a local filter right here. In this interface, you can see the x and y of the selected curve. Here we have a window for further adjustment. We will see it in a second. We have the load curve button. Load curve will load actually the curve. And we have the point name and, more important, the point ID. This is a unique an ID that 3dqualizer uses internally as 3D in its database. So if we load this curve, now we can see and we can move the x and y window, but we really want to, the y curve isn't too bad, but we want to modify the x one. So if we applied a general local filter, we will obtain a general filter. If this is a range, if we apply Fourier filter with a cutoff 0, 1 and the minimum and 2 the maximum, and we click global preview X, this button creates two curves we can see here. The white is the initial curve. We have two other curves. The red one represents the minimum filter, and the blue represent the maximum filter with 2. So clicking this, we are applying an entire filter to the curve. For example, if we have this curve, we want to 3dqualize, optimize this curve. And if we put a value low here, 0, 1, we can see that the red one is really close to the white, that this is our main original curve. You can see the red one is really next. But if we use a high value from the top cut of filter, we can see that now we have a blue line, and this blue line is is the white curve filtered using this value. So the idea is to say to 3dqualizer, please take this white curve and optimize it from this value red to a value of blue. So the curve should make a transition between the white, between the red and the blue, and we can define what is the range. But this is only a preview. We are only previewing results, and we can do the same if we want to do a general optimization. We can use here global preview on X. We can use Y to preview this. We can use X to add to the general list of optimization here, and Y to add the general curve filter to the list. And this, what does it mean? ED244AC is the ID, 129 and 422 are the range of the camera, and 0, 1 and 4 are the filter to apply. And this is the same for the Y, and the difference only X and Y. We can delete one by one, or we can delete all. For example, suppose that we have this curve, but we don't want to optimize all the curve. We want only to optimize the first part of the curve, because the end part is pretty stable, maybe. So we can do a local optimization. We can optimize, for example, between frame 129 and 250. Local preview. So we are optimized the curve only in this part using this range. For example, we could optimize this, and we can press plus X, and it will add to the list another optimization parameter. ED244AC is the name, the loading point ID. X is the axis that we are going to optimize. And we have 129 and 250 are the range of optimization, and 0, 1 and 4 are the range of local filter. But we want also, for example, to optimize the end of the curve. For example, between 350 and 422. So we can preview this part only. Always between this, or maybe ls. After that, we can add, for example, this plus X. And now we have two optimization. If we open a Windows parameter adjustment window, we have nothing. But if we click one send to adjustment, it will send here. We can also send it multiple times, but this isn't useful. And we can send also all of them, pressing send adjustment all. So we can delete one by one, we can delete all, we can send adjustment, or we can send adjustment all. We press send adjustment all. Now we have the custom data, we have the two range of filtering, and after that we can optimize this point. You can use this, for example, and we can press adjust. So we can adjust both curves using these parameters. You can do this. Now the script is trying to adapt the curve between this range, that this and this range is this one listen, the B script, and the A script between 129 and 250 using this range. And you can see that actually the best here is 2.519 here. Now it's 2.8 here, and we can wait the end of this. Is not too long, and you can press transfer parameters. Now parameter have already overwritten the original curve. But if we press load curve again, we can see, without closing these windows during the parameter adjustment, we can see the new curve. So we can see now the green one is the new optimized curve. So using this 1.9 in the first part between 129 and 250, here in this part, we can see that we have this optimization right here. And in the end, we have the green, and this is the variation between the variation applied for the second adjustment. So these red and blue lines are the previous preview. In fact, if we do a local preview between 129 and 25, between 0, 1 and 4 on the X, we can see that the white was the original curve, the red curve was the starting point of filtering by 0, 1, the blue is the 4 for maximum filter, and using optimization, 3dqualizer decided the best should for minimum deviation should be 1.94, and so applying a Fourier filter of 194 to this range between 129 and 250, we have this curve, this green curve, so we can visualize this. And at the end, instead, if you go to the end and we apply 350 422 between 0, 1 and 3, this was what we created. So the white was the original, red the minimum, blue the top, and we can see that choosing 2.84 it's very close to 3, the maximum, and you can see that the green curve is really next to the blue one. So we divided the original white curve. Here is the same because we haven't changed nothing, and here is the difference between the original with the green, and also here we see the green respect of the white. After that we can calculate from scratch. You can see now the point is more stable. We can calculate from scratch. We can see that now the deviation is better. Now the point is more stable. And if we are happy of the results, we can close this, or for example we can restore, and pressing restore the curve will be restored. For example, if we press restore, now the original white curve is being imported into 3dqualizer, and now on 3dqualizer we have again the red curve, and if you do calculate from scratch again, you can see here a high deviation But if we do the adjustment, because we are already here, we can do the same as before, and we can obtain the same result. The important part to consider is that this script only uses parameters points and x for x and y coordination, and the range between frames. So the actual filtering script is working on selected point in selected camera group, in selected point group in selected camera. So when you optimize a curve, you should add it using 2D core local filter and optimize without changing the camera, because the script is working on actual selected parameters. Okay, here we go, we have the same. And now if we want to, now we have the curve like before, we can calculate from scratch. We have 3D point, the deviation is lower than before. And if we want to further improve the results, we can import this. So now we can restore anymore, and we can add other pieces to this curve, add other adjustment, and so in this way modify again. The same is for x or y, is the same. We can add all adjustment that we want. And that is the 2D local filter editor. I think could be improved. If you have any suggestion, if you find bugs, I don't know, could be improved, but it's a trade-off between changing points frame by frame, or between each frame, or using adjusting 2D curves on singular points, and a trade-off between these and to apply a general filter without knowing how is the best. So this can apply a general or a localized, or both. You can apply this and this, and so you can let the 3dqualizer optimization script calculate what is the best solution between our defined ranges. It could be useful if you have a shaky. Now if you can see, the deviation is lower and we don't have anymore a lot of peaks in the curve. You can use this local filter usually on all points in the scene. The important part that all points that we had two parameter adjustment are inside the same point group and the same camera. So I think we can take this, I can load this one, I can apply, for example, this, I can send to adjustment. So here I have this. If I select another point, this one for example, I can load this. This is shaky. I can apply a filter here, for example only on to the x-axis, and then add. So into this I have 2 points different, you can see EAC and AAC, X both, and both on general filter. You can do this, you can adjust this, but the important part that you should remain on this camera group and source, because these scripts are working inside the selected point group and camera. If you find any bug, if you have suggestions, please let me know using email or GitHub. You will see in the description. I'll add the links to scripts. So thank you for your time. I hope that you use this script, or if you further improve it, please let me know. Okay, so bye, and thank you again for your time.